concept causes a little more confusion, and that is when an angle is formed by two chords. Right, so if the angle is formed by two chords, that means the vertex is going to lie in the interior of the circle, and the relationship that holds true here. So again, I'm just going to use angles 1 and 2, although the other pair of angles could work. If we looked at both the intercepted arcs, M and N here, if the vertex lies in the interior of a circle, the angle is going to equal the average of the intercepted arcs. So the average of the intercepted arcs is basically calculated as 1/2 the sum of the arcs. And so we can think of this in the form of an equation. So if we think of this as an equation, we get angle 1 is equal to the average, so 1/2 the sum of m plus n. And it doesn't matter whether you're finding angle 1 or angle 2 because they're the same, right? They're vertical angle pair, so they are equal to each other. So there is another way that you can think of this. Right? And so you can think of this, if we wanted to get our m plus n alone on one side, get rid of the fraction, what would we have to do to both sides of this equation? Multiply by 2, right? So 2 times angle 1. Well, if angle 1 and angle 2 are the same thing, twice angle 1 is equivalent to saying the following relationship. Angle 1 plus angle 2, so that's kind of like saying twice angle 1, that has to equal m plus n. So you can think of it in this form too. It doesn't fit with the wording of the relationship, but the relationship is true nonetheless. Okay? So when you're looking at an angle whose vertex lies in the interior of a circle, the sum of the two angles that are formed inside, the vertical angle pair, has to equal the sum of the intercepted arcs. All right, questions about those relationships? If you're somebody who does kind of mental calculations or doesn't write your work down, you're probably going to want to use this form. And if you're somebody who writes all the calculations just to confirm your work, you're probably going to use this form. So let's take an example of a couple problems like that. Okay, see if you can find the missing arc measure here in this example. All right, so if you're organizing, you write all your work down. What you have is you have this angle, so we're going to look at the intercepted arcs between it and its vertical angle pair. So we're going to look at M and then this arc measure of 112. So we know that our angle has to equal the average of the intercepted arcs. So M plus a 112. Okay, and so we can substitute what we know. Our angle is 80 degrees. And so now we have just the one unknown. If we multiply both sides by 2 to get rid of our fraction, we get 160 is equal to M plus 112. Subtract a 112 from both sides, and we get our solution. M is equal to 48. Okay, now, if you're somebody who prefers just to look at the problem and kind of calculate it in your head, what you're probably going to do is you're going to say that the sum of these two angles, 80 and 80, has to equal the sum of these two arc measures, M and 112. So to you, again, your thought pattern is 80 plus 80 is equal to M plus 112. You wind up getting the same calculation. 160 equals M plus 112. M is equal to 48. And it's just, again, you might not be writing this down for you. You might be doing the calculations in your head. Either way is fine. All right, so this problem, again, pretty straightforward stuff. You have an angle whose vertex is in the interior of a circle, so it's going to equal the average of the intercepted arcs. So it's going to be 1/2 of 40 plus 54. And if you calculate that through, half of 94 is 2 goes into 9 4 times, with 1 remaining. 2 goes into 14 7 times. And so you get 47 for your angle measure.